Hi all, welcome to a new video. This video is about the clipper circuits, and this video is actually a quick revision from the exam point of view. Here we'll be discussing about the basics of clipper circuits, the general classification of clippers, and we'll see the working of some of the basic clippers. So let us begin. Okay, so what is a clipping circuit? A clipping circuit is basically a wave shaping circuit. That means it controls the shape of the output waveform. That is done by clipping or removing a portion of the input waveform applied to it. Okay, so that is a clipper circuit. And what are the essential components of a clipping circuit? Those are diodes and resistors. These are compulsory components of a clipping circuit. And in addition to that, you can sometimes use batteries as well, depending on the output waveform required, shape of the output waveform required. If you are using a battery in addition to diode and resistors, then we say that is a biased clipper. If you are using only diode and resistor and there is no battery employed, then we say that is an unbiased clipper. Okay. Now clippers can be broadly classified into two types. Those are series clippers and shunt clippers. Series clippers means the diode will be connected in series with the load resistor, while in a shunt clipper, the diode will be in a parallel connection with the load resistor. First, let us see the working of a series type clipper. So let's see. As you can see in the figure, the diode is connected in series with the load resistor, and when we apply a sinusoidal waveform at the input, during the positive half cycle, according to the connection of the diode will be reverse biased, and therefore it will act as an open switch. So there won't be any output at the load resistor, and so the positive half cycle will be clipped. But during the negative half cycle, this diode will be forward biased. So what happens, it will act as a closed switch, and the negative half cycle will appear as it is across the load resistor. So as you can see, in the output waveform, there will be only negative half cycles and the positive half cycles are completely clipped off. That is why this kind of clippers where a positive half cycle is clipped is known as a positive clipper. Okay. Now when you just flip the connection of diode, that is, if it is just rotated 180 degree, what happens? During the positive half cycle, this diode will be forward biased, and therefore it will act as a closed switch, and the input positive half cycle waveform will appear as it is across the load resistor. But during the negative half cycle, this diode will be reverse biased and there won't be any output at the load resistor. So here we are clipping off the negative half cycle, and hence it is known as a negative clipper. In both the above discussed cases, we have considered the diode to be an ideal diode. But in the real case, even though a diode is reverse biased, there will be a small reverse leakage current flowing through the diode. So instead of completely clipping off the clipped half cycle, there will be a small voltage drop across the load resistor even when it is reverse biased. So the clipped half cycle will not coincide with the x-axis. It will be slightly above with a small voltage drop above the x-axis. Okay, that you can see in the figure. When the case of a real diode, this will be the case. Instead of ideally completely clipping off the half cycle, there will be a small voltage drop during the reverse bias condition. Now let's move on to the shunt clippers or parallel clippers. As you can see in the diagram, the diode is connected in parallel with the load resistance. Okay, so when you apply an input sinusoidal waveform, what happens? During the positive half cycle, the diode is forward biased, and hence it will act as a closed switch with zero impedance. So what happens? There won't be any voltage drop across both diode as well as the load resistance, which is connected in parallel to it. So during the positive half cycle, there won't be any output at the load resistor, and thus the positive half cycle will be clipped. But during the negative half cycle, the diode will be reverse biased, and hence will act as an open switch, and therefore the entire voltage of the input will come across the load resistance. For that, the value of R should be much less than the load resistor. Okay, so thus you will have only the negative half cycle at the output, and hence this is also a positive clipper, but this is a shunt clipper. Okay. Now if we just flip the connection of the diode, what happens during the positive half cycle, the diode will be reverse biased and hence will act as an open switch and the entire voltage will come across the load resistance. But during the negative half cycle, the diode will be forward biased and it will act as a closed switch. So the negative half cycle will be clipped. In all these cases, we have considered the diodes to be ideal and hence we are not considering the reverse leakage current and the concerning voltage drop across the diode. Okay, that's why we are showing as the half cycles to be completely clipped off. If that's not the case, if the diodes are real, you'll have to show a small voltage drop across the diode even in the case of reverse bias. Now we'll see the working of a bias clipper. Okay, bias clipper means we are connecting battery in addition to diodes and resistors. Okay, the essential components are diodes and resistors, and in addition to that we are connecting battery in the circuit. Then that becomes a bias clipper. So let us see the circuit. As you can see, we have connected a battery in series with the diode. Okay, so consider the positive half cycle. During the positive half cycle, because the negative potential is connected to the P junction of the diode will remain reverse biased throughout the positive half cycle. So what happens, the diode will act as an open switch, and so you can neglect the branch containing the diode and battery. The entire input voltage will come across the load resistance, and for that keep in mind the value of R should be much lesser than load resistance. Okay, if that is the case, the exact input will come across the load resistance during the positive half cycle. Now during the negative half cycle, as long as the amplitude of the input signal is less than the battery voltage, what happens, again the N junction will be more positive compared to the P junction of the diode, because the amplitude of the input signal is lesser than the battery voltage. Again in that case, the diode will be reverse biased and it will act as an open switch. So again that branch can be neglected and the exact input voltage will come across the load resistance. But when the voltage of the negative half cycle exceeds the battery voltage, the diode will be forward biased and it will conduct heavily. So what happens, the voltage will be stabilized at V, because it is connected, the load resistance is connected to the battery, is connected in parallel to the battery. So the battery voltage will appear across the load resistance. Okay, so as you can see in the output graph, the output waveform shows that the negative half cycle, when the amplitude exceeds V, is clipped off. Okay, as long as the battery voltage, as long as the input voltage is lesser than V, you will get the negative half cycle. But as soon as it exceeds the battery voltage, that portion will be clipped off. That portion of the negative half cycle will be clipped off and the voltage will be stabilized at V. Okay, so this is a negative clipper where the negative half cycle is clipped at V. Now let us see a biased positive clipper. For that you have to just flip the connections of diode and also the connection of battery. Okay, so as you can see in the figure, you have just changed the connection of battery and diode. So let us see what happens during the positive half cycle. As long as the diode is reverse biased, you will have the input signal as it is across the load resistance. Okay, as long as the voltage is not exceeding the battery voltage, you will have the signal as it is across the load resistance. But when the input signal exceeds the battery voltage, what happens, the diode will be forward biased. So when it is forward biased, the battery comes into play, and thus the voltage across the load resistance will be stabilized at V. During the negative half cycle, throughout the diode will be reverse biased, so no problem, you can neglect the branch containing the diode and battery. So the entire voltage of the input waveform will be coming across the load resistance if R is much less than RL. Okay, so this is a biased positive clipper. So that's it. We have seen the basics of clippers and we have discussed the working of some of the commonly used kind of clippers. Okay, thank you.